All right, so the first problem we have here, and I'm sorry it's so small. I have to do a better job next time of making this print larger. But what we have is Norichi. I hope you can read that. Norichi left the White House and traveled toward the lake at an average speed of 65 kilometers per hour. Sometime later, Emily left traveling in the same direction but with an average speed that was different from Norichi. She was traveling at 78 kilometers per hour. After traveling 5 hours, Emily caught up with Norichi. All right, so that's an important sentence right there. Emily caught up with Norichi. How long did Norichi travel before Emily caught up? All right, so let's take a look at this problem. Let's try to make it as clear as we can. If I say anything that's unclear, hopefully you call in. All right, but let's just, we've got a distance traveled here. Let's just say from here to here, this distance is what Norichi called. Let's just call that N. That's Norichi. And then here's another distance. Let's say right here, from here to here. That distance we'll call E. All right, that distance we'll call E. So I've made these distances the same. That's very important for you to see that. And the reason why I made these distances the same is it says that Emily caught up with Norichi. Regardless of who left first, if one person caught up to another, this person traveled a certain distance, and if Emily caught up with Norichi, she traveled the same distance. It's very important with regard to this problem. All right, so let's read it again. Norichi left the White House and traveled toward the lake at an average speed of 65 kilometers per hour. One thing that we need to be aware of is the distance of Norichi obeys a very important formula we'll be using throughout each of these problems that we work on today. Distance is equal to rate times time. And then the distance of Emily also obeys this formula. Distance is equal to rate times time. It's the backbone of everything we're doing today. All right, so this problem gives you the average speed of Norichi. So let's substitute that into the rate, which is 65 kilometers per hour. All right, and then it says sometime later, Emily left traveling in the same direction, but see, Emily had a different speed. All right, so Emily, let's substitute into R here. Emily had a speed of 78 kilometers per hour. Now, all we have to do is just figure out the time here. This says after traveling for 5 hours, Emily caught up with Norichi. After traveling for 5 hours, Emily caught up with Norichi. So that's telling you that Emily traveled for 5 hours. So you'd substitute that time into the time for Emily. That's 5. All right, so now you've got the total distance that Emily traveled, because the distance formula for Emily is rate times time. And I neglected to bring my calculator, but fortunately I have my phone. But actually, this is an easy calculation. Let's just do it by hand. 78 times 5, 435. That's 390. All right, so 390, and the units here would be kilometers. So Emily traveled 390 kilometers. The question would like to know, how long did Norichi travel? How long did Norichi travel? All right, so that's the time for Norichi. So you just put T here. Because these distances are the same, we talked about that already. You could solve this equation by just saying 65T is equal to 390. You divide both sides by 65. Divide both sides by 65. And I think what you end up there is 6 hours. 6 hours. All right, so that's your final answer for that problem there. All right, so let's look at a different kind of problem. Okay? This kind of problem It's number 2 here. Number 2. And again, I really apologize that this print is so small, but I'll read it for you. It says, an aircraft carrier left Hawaii 1 hour before the fishing boat did. All right, so the aircraft carrier left Hawaii 1 hour before the fishing boat did. The ships traveled in opposite directions. That's how this problem is different from the other one. The ships are traveling in opposite directions. In the other problem, the two people were traveling in the same direction, and one person caught up with the other person. This one, the ships are traveling in opposite directions. The fishing boat traveled at 30 kilometers per hour for 4 hours. After this time, the ships were 270 kilometers apart. What was the aircraft carrier's speed? All right, so I'm reading it very carefully, as I'd like you to do as well when you're solving really any kind of problem, not just this kind of problem. All right, so here we go. Let's take a look at it. All right, so you got one, let's call this the aircraft carrier, maybe AC, call it the aircraft carrier. And then you've got the fishing boat, and I'm drawing it in the opposite direction as the problem stated. Fishing boat, let's label that FB. All right, so it says the ships travel in opposite directions. And it says the fishing boat traveled 30 kilometers per hour for 4 hours. So again, the backbone of this entire worksheet that I'll be working from is the fact that all these problems are rooted in you understanding that to get a certain distance, you need to multiply the rate times time. Distance is equal to rate times time. All right. So this says the fishing boat is 30 kilometers per hour. It's traveling at 30 kilometers per hour. Let's substitute that. 30 kilometers per hour. And they also tell you that it's been traveling for 4 hours. So let's multiply that by 4 hours. All right, so hours cancel here, and you end up with 120 kilometers. 120 kilometers. All right, so now it says after this time, the ships are 270 kilometers apart. So what I'd like you to be able to see here is hopefully we can maybe put this up top here and it's clear to people. Let's put the distance from here to here. You got the fishing boat traveling in this direction. You got the aircraft carrier traveling in the other direction. But it says that after this time, the ships are 270 kilometers apart. So let's just make that distance 270 from here to here. So I'd like you to be able to see if the distance between here to here is 270, and after 4 hours, this fishing boat traveled 120 kilometers, I'd really like you to be able to see, to get this distance that the aircraft carrier traveled, it's just a simple subtraction of 270 minus this 120 here. And if you do that, you get 150. So to get the distance traveled, it's just a basic calculating of the 270 minus the 120. And like I said earlier, you just get 150. That's the distance of the aircraft carrier. Then it says it says one more time, the aircraft carrier left Hawaii 1 hour before the fishing boat. So as far as the time is concerned, the aircraft carrier left 1 hour before the fishing boat. If you notice here, it says the fishing boat traveled for 4 hours, but the aircraft carrier left 1 hour before the fishing boat. So what that would mean is that the amount of time that the aircraft carrier was traveling was actually one more than the boat, which would make that time 5. Okay, once again, one more time. It says the fishing boat traveled 30 kilometers per hour for 4 hours. That's the fishing boat. This was traveling for 4 hours. For 4 hours. All right? But the aircraft carrier left 1 hour before that. The aircraft carrier left 1 hour before that. Well, if this was traveling for 4 hours and the aircraft carrier left 1 hour before that, that would mean that the aircraft carrier was actually traveling for 5 hours. So I substituted the 5 in for the time here, and the thing that they're asking for is what was the aircraft carrier's speed. That's another word for speed is rate. All right, so now you end up dividing both sides by 5, and then you get the rate is 30. The rate is 30. All right, 5 divided by 150 is 30. All right. All right, so that's what we would. Oh, by the way, the units would be kilometers per hour. Kilometers per hour. All right. All right. So let me just take a look at this one more time. We got the distance of 150. The rate's unknown. The time, yeah, that looks good. All right. So that's what we're going to go with.